In previous videos, we introduced a very high-level model of agents and the decision-making that they do. And it was very high-level in the sense that it didn't make any kind of commitments or tell you very much about how you might actually go about implementing such agents. It just tried to model the decision-making that agents do at a very, very high level. So what we're now going to do in this video is to start to decompose that high-level model into a number of subsystems. And this decomposition isn't going to be complete because you still won't be able to implement an agent after you've seen this decomposition, but it will give you a flavour of some of the kinds of subsystems that you will find in actual agents. And in later parts of the book and in later videos, we will see some concrete instantiations of these subsystems. We will see exactly what they look like in real agents. So, the first idea that I'm going to introduce is that it's not really a decomposition at all, but the idea that our agent's decision-making is what's called purely reactive. And these are very, very simple kinds of agents that are simply responding to their environment. So they're not attempting to do any kind of reasoning about what action to perform or any sort of high-level problem solving or thinking about what action to perform. They're simply responding to the environment. Okay, so purely reactive agents are essentially just lookup tables, or rather the decision-making in a purely reactive agent is essentially just a lookup table. What our agent does is it has a lookup table where on the left-hand side of that lookup table are environment states, that is, possible configurations of the environment, and then on the right-hand side of that lookup table are corresponding actions. So in order to decide what to do, all our agent does is it looks down this lookup table until it finds an environment state which matches what it sees in the environment at the moment, and if it finds a match, then it performs the corresponding action. So decision making is just look down this lookup table until you find an environment, until you find something which matches what you see in the environment and perform the corresponding action. So formally, we model these purely reactive agents via these what we call action functions, which simply take as input an environment state and give as output an action. So this is the left-hand side of the lookup table and this is the right-hand side of the lookup table. So this action function takes as input an environment state and simply says, okay, if this is the state that you see in your environment, then this is the action that you perform. So a thermostat, for example, can be thought of as a very simple kind of one of these purely reactive agents. What does a thermostat do? Well, it looks at its environment state, and it's really got only two notions of environment state. It's got temperature okay or temperature not okay. And if the temperature is okay, that is in an acceptable range, then switch the heating off. If it's not acceptable, then switch the heating on. So all this agent has to do is try to find a match between the environment state that it sees and whether or not the temperature is okay or not, and perform the corresponding action. So very, very simple kinds of decision-making in purely reactive agents. But for moderately complex tasks, anything that's beyond trivial, building these kind of purely reactive agents, trying to build them in this kind of lookup table way, while it's actually very efficient in terms of the amount of time it takes to make a decision, because all you're doing is looking down the table, actually building them that way is just not practical. So what do we do instead? What we do instead is we start to decompose our agent into subsystems. And the top level decomposition that you can think about is into perception and action subsystems. So here what we've done is we've broken our agent's decision making down into two parts. There's a perception part and an action part. So how to explain the perception part of an agent? Well, the idea is, the way to think about this is think about a mobile robot that's busy moving around the real world, and imagine that it has some sensors on it. So it could be a video camera, or more likely an infrared rangefinder or a laser rangefinder or a sonar or something like that. And that's giving the output of that system, is giving the agent some information, some perceptual data. It's giving the agent some perceptual data about its environment. And we call that perceptual data a percept. A percept is a piece of perceptual data. So we model then this C function this perceptual component of our agent, we model that as a function which just says, okay, if this is the environment state I'm in, then this is the percept that I'm going to produce. So the video camera is looking at the environment and it's producing as output a percept. So PER here is the set of all possible percepts, the set of all possible bits of perceptual data. So then the action selection subsystem that we think of an agent having, previously when we looked at an agent's, in the very abstract model, we looked at an agent's decision making, what we did is we said it looked at the whole history of the system so far, environment state action, the whole history of that system, and then decided what action to perform. Well, here what we're saying is it looks at it takes into account all the percepts that it has received. So if I have received this percept, then this one, then this is the action that I'm going to perform. Whereas if I've received this percept, then this percept, then this percept, then this is the action that I'm going to perform. So it just takes as input, the action selection system takes as input a sequence of percepts and decides what action to perform on that basis. So we're dividing an agent just in this top level way down into perception and action. The output of the perception system is a percept, a piece of perceptual data. Well, still, of course, this isn't giving us really terribly many hints about how to go about actually implementing these. So let's do a further, very natural decomposition and start to think about agents as maintaining state. So the idea now is an agent has an internal state which it can update every decision cycle. Every time it goes through this sense, decide, act decision cycle, it's going to update its internal state. So the perception system is the same as before, it's just producing this percept, but now there is this next state function, very similar to automata-like models. The next state function says, okay, if this is the perceptual information that I'm getting, this is the input from my environment that I'm perceiving, and this is the current state that I'm in, then this is going to be my next state. So think about this next state function as deciding what to record about the state of the environment. Anything that the agent wants to remember has to be written into that state. And then all the action selection subsystem does is says, well, if my state looks like this, then this is the action that I'm going to perform. So the action selection subsystem, all it does is it looks at the internal state, and on the basis of that internal state, decides what action to perform. So the basic operation of our agent is look at the environment, which generates a percept, a bit of perceptual data. Update my internal state, and then this updating process takes as input both the current percept that I'm getting and my previous state, and that results in a new state being generated, a new internal state. The action selection function just looks at the internal state and decides what action to perform. Okay, so the next state function then, big I here is the set of all possible internal states. The next state function says, okay, if I'm currently in this internal state, and this is the perceptual input that I'm getting, then this is going to be the next state. So it takes two inputs, the current internal state, the current percept that's being given, and it returns as output the next state that our agent is going to go in. Okay, and then the action selection function just says, well, if this is my current internal state, then this is the action that I'm going to perform. So the agent control loop is just repeat this loop forever, look at the environment through my C function, update my internal state via my next function, which says what I'm going to remember, choose an action to perform via my action function, and perform it, and just continually go through that loop. Now, of course, what we haven't said in any detail is exactly what those internal states are going to be, what those percepts are going to be. These are exactly the issues that we're going to explore in the future.